Hey guys, let's discuss new traversal algorithm from graph, which is called DFS, depth first search. So in my earlier video we have discussed about BFS, breadth first search, okay, and now we will discuss about DFS. So I told you in that video that for BFS, okay, for BFS we use Q data structure, okay, Q data structure, and for DFS we will use recursion stack, you can say, right? Recursion use the stack data structure. So this is the difference between that. So for example, let me quickly explain you BFS and DFS difference. So for example, you have a vertices like 0, 1, 2, 3, 4, and then this it is connected to 2. Okay, so this is your graph. Okay, it could be cyclic, it cannot be cyclic. Okay, so all trees are graph, but all graph are not tree, you know that, right? Now here if I wanted to traverse this graph into BFS format, okay, so what it will be, first it will traverse 0, and then next level 1, 2. How you are deciding levels? Using the number of edges between those two vertices. If here let's say you have a 5, then this 5 will also come into the level 1. Okay, so this is your level 0, this is your level 1. Okay, because the number of edges is 1. Now you will visit all the, for level 2 you will visit all the edges which has all the vertices which has 2 edges. Okay, so from 0 to 1, 1 to 3, so this 3 will come in level 2. Okay, 0 to 1, 1 to 4, so okay, 4 will also come into level 2, and that's it. Okay, so this one will come to level 2. So level wise you are traversing here. Now what is the difference between DFS? Okay, so and we were using Q there. Now if let's say the same graph, if I wanted to traverse DFS wise, this is 0, let me create once again, 0, 1, 2, okay, 3, 4, this is connected to this, and 5. Okay, and let me remove this one. So now in DFS what you will do, you will take one node, let's say 0, okay, DFS 0 for example. So you will go depth wise. So first you will go to 1. So in BFS what we were doing, we were traversing all its adjacent nodes, okay, neighbor nodes, so 0, 1, 2, 5, but here you just take 1, okay, then from 1 where you will go from 0 to 1, then from 1 where you will go 3, okay, then after 3 nothing is connected, so again I will be back to 1. So from 1 where you will go 4, okay, then from 4 where you will go 2, okay, then from 2 where you will go 0, okay, so again 0 is visited, so then from 0 where you will go 5. So this is how you will traverse in the DFS. Okay, so that's why we use here recursion. Now let's see what is happening in the code. Okay, how we store graph first, and then so how we store graph, we are using here adjacency list, okay, linked list of linked list, and I have already explained how we will store that into the adjacency list, how we will store the graph into adjacency list in the BFS video lecture. You can go and check there, but let me explain it quickly. So for example, if someone will ask you to create a graph, okay, so first you will create a linked list of size V. Okay, V is given here 7 for example. So I'll create one linked list of size 7. Okay, 3, 4, 5, 6 and 7. I will call it as adjacency list. Okay, this is 0, 1, 2, 3, 4, 5, 6. If I wanted to access this one, I will write it as adjacency 0. Okay, and then inside this list, each node of a list, you can create new list itself. So you can have a new list here, and you will create it also. Okay, using the for loop you will create this list. So here you have created one linked list, okay, which is called ADJ, and then inside that using this for loop I equal to 0 to V, you will create in each ADJ I, you will create one linked list. Okay, now now what is given? So if G dot add age 0, 1 means there is a age between 0 to 1. Now if it is undirected graph, so it means that if there is a age between 0 to 1, then definitely there is a age between 1 to 0, right? This is 0, this is 1. If this age is there, means you can go from 0 to 1, but you can also go from 1 to 0 as well, right? So in that case what you will do, if something is given 0, 1, so you will add one node here 0, 1, but you will go to 1 also, and you will add the 0 here. Okay, next is 0, 2. So 0 you will come here, you will check, okay, node is there, node is not null, so you will go to end of the linked list and then add your node 0, 2. Now let's go to 2 and add this 0 again. Okay, 0 to 2, 2 to 0. Now 3 to 4, so you will go to 3 and add it here 4, in 4 add it 3. Okay, and now 5 to 5, 6, so 5 to 6, 6 to 5. So this is how you will create a linked list. So your this graph DFS constructor is done. Okay, this is the structure of this graph DFS, one vertices and one linked list, and this is your add age is also done. Okay, now we will come to the actual logic. Okay, DFS logic. So you will simply run g.dfs. Now what DFS function is doing? So this DFS function it has created one visited array. Okay, visited array you would always be required, because if there are non-connected components, okay, for example if your graph is something like this, 0, 1, 2, then 3, 4, 5 and 6, so see they are not connected, okay, but they are a part of a graph, and you need to traverse all the vertices. Okay, so for example this is 1 component, 2 component, 3 component, 4 component. So how you will switch between the components, like 0, 1, 2 you have already traversed, but then how you will go to third one, how you will go to fifth, sixth, they are not connected, right? So that's why we use this visited array. Initially everything will be false here. Okay, now you have created one visited array with one for loop. Okay, 0 to less than v, you will check each node in a visited array. Okay, so this is in visited array, each this indices represent the nodes. Okay, so vertices 0, vertices 1, 2, 3, the status of that, whether it is visited or not. So initially you will run this I equal to 0. Okay, so visited 0 is not true, right? Not function is not operator is there, right? So you will run this DFS util with I equal to 0 and visited array itself. So I equal to 0, what it will do, this is the actual logic. Okay, so node it will come with 0. Okay, so visited 0 equal to 2, so it will mark it to true, and then it will run. So currently we are running DFS 0. Okay, and then it will print this node. So this 0 will get printed. Let me remove it. Okay, let me print it here itself. So this 0 will get printed here. Now what it will do, it will traverse all the adjacent node, neighbor node, okay, of this DFS depth first search. Yeah, it will traverse all the neighbor node of this 0. Okay, means this one we are talking about, this linked list. So 1 and then 2. So in BFS what we were doing, first we were visiting 1, and then at the same time we were visiting, once 1 was completed we were visiting 2. But here we'll go to depth wise. So first you will go to 0 to 1, then 1 pointing where, and then that one is pointing where. So we will go depth wise. Okay, so that is the difference. And then now go to, so you will get 1 and 2. So first you will check for 1, neighbor 1. Okay, it is not visited, so you run this DFS util function. Okay, again for neighbor 1, so DFS 1. Okay, now whatever will happen here, we will come on that later, but let's see what is happening in DFS 1. So once this DFS 1 again with visited node equal to true, so this one will mark as true. Okay, for visited 1, and then it will go to all its neighbors. So visited 0, you will come to 0, but 0 is already visited, right? So you will not do anything. So DFS 1 will run for DFS will not run for DFS 0. Okay, so now you will come back from here, DFS 1. Okay, now again it will run for DFS 2 now, because next neighbor will come here. 0 and 1 and 2 was there, right? 1 and 2, so 1 is completed. Now it's time for 2. So let's check what is happening in DFS 2. So DFS 2 it will go, and then again it will check for DFS 0, but 0 is already visited, so you don't need to do anything. But when you come to 2, you will mark it to 2. Okay, now you're printing node also, okay, one by one. So first 0 got printed, then 1 got printed, now 2 got printed. 0, 1, 2 is done. Now after that nothing is there. Okay, it means that we are completed with this 0, 1, 2, 1 component. But now what about other components? So that's where our for loop, this for loop will come into picture. Okay, so you have already run it for I equal to 0. Now I equal to 1, it will check, oh, it is already visited. So I equal to 2, it will check, it is already visited, no need to process further. I equal to 3, so it will check, no, it is not visited. Okay, so it will run DFS, it will run for DFS 3. Okay, this one you don't need it now, it is done. Okay, so DFS 3 it will check, and what it will check in DFS 3, oh, 4 is there, so it will run for DFS 4. Okay, 3, 4, so 3, then after that 3 will get printed, 4 will get printed. Okay, and then DFS 4, what it will do, nothing, it has no node connected with it. 4 is connected with 3, but 3 is already printed. Okay, this is 0, 1, 2, 3, 4, 5, 6, so 4 is already done. After that it will check for next one. Okay, 4 is already visited. 5 it will come, so 5 is connected with 6, so it will mark it to true, it will print this 5. Okay, and then it will see this one, DFS 5 got printed, right? No, DFS 5 will be here, not part of 3, 5. Okay, so it will run DFS 6. So 6 will say, okay, this one will mark as true, visited array, and 6 will get printed, and then 6 will say, okay, 5 is already visited, and you're done with your for loop. So this is what you have the answer, and this is your DFS traversal. So that's it. Thank you.